Hello viewers, tutorial 11 question 2, and we're finding some integrals involving exponential functions. So recall that if we differentiate e to the power of x, we get e to the power of x. So differentiating e to the x gives you the same function. Also remember that integration is the opposite of differentiation. So the opposite of something that gives you the same must be something that gives you the same. So that means that the integral of e to the x is also e to the x. And the integral of e to the t, well, we're changing just a letter, but the concept remains the same. So that's still e to the t. Now what about the integral of e to the 2t? If we were to differentiate that, we would get e to the 2t, the power would stay the same, but we need to multiply by 2 by the chain rule. So we would get, if we were differentiating, we would get 2 e to the 2t. Integrating means we do the opposite, so instead of multiplying by 2, we divide by 2. So we get e to the 2t divided by 2. Now if we were to differentiate that, we would get 2 e to the 2t over 2, and the 2's would cancel to get us back to e to the 2t. Okay, so same thing here. If we integrate 10 e to the 2t, we get 10 times e to the 2t over 2. So we would get 5 e to the 2t plus constant. E to the x, as we said, if we integrate it, we get itself. So we get e to the x becoming e to the x. So 6e to the x would integrate to 6e to the x minus integrate e to the 3x, we get e to the 3x divided by 3. So 12e to the 3x would integrate to 12e to the 3x divided by 3, and then would work out the 12 divided by 3, which gives us 4e to the 3x plus your constant. Okay, thanks for watching. Over and out.